My name is Bismarck Perez,
And my name is James Martin.
and this is our video for our AI class project. For our project, we decided to go with a genetic algorithm used for a car parking game. The reason we did this was just because we felt like while we were both very familiar with genetic algorithms, with the genetic algorithm experience we had in class, we felt like there was a lot to improve on with the algorithm itself and with our implementation of it. So that is why we chose to go with a genetic algorithm approach. As to why we picked a car parking game, um, we needed to find a simple game or a puzzle in which genetic algorithm would actually be applicable, where we could slowly move towards a target and get better with each generation. For our project, we did a car parking because we could gauge the performance on our car with the distance to the parking spot. So the goal for our car is park in the parking spot and avoid any other cars. So we used our genetic algorithm with that performance metric of having it get slowly closer and closer, and then eventually the genetic algorithm will automatically stop once it reaches its target without having hit another car. To show how we coded this, James Martin will take over.
We went with using Pygame to create the user interface. That's what creates this nice little screen here. The car will move from its point to the highlighted parking spot. When the game restarts, the parking spot will move. This way we're actually making sure it's not just going to one location. It will test all different locations. Uh, the genetic parking, the genetic algorithm basically follows the principle of let's create a random population, let's run that population through a fitness test. Once done, it's going to spawn children, and then it's going to run it through the fitness test again, and it's going to continue doing that through multiple generations until it finds the closest slash best solution. Our improvements that we went with on this is we wanted to first improve the fitness test to try to correct if the car goes off course. So if the car starts driving off this way, we want to be able to say, okay, bounce, try to get back onto the screen. It could be plausible that if it's getting close to an edge case, that it could bounce off screen, but that might have been a good solution if it comes off screen, comes back and lands. And we didn't want to just start dropping those solutions. Another change that we made is after the fitness test, we do this elitism where we're sorting the best outcomes and then purging a certain number of them that don't meet that don't meet the qualifications. And then with that smaller population of the best answers, that recreates the population back up to our original population size. So in some cases, depending on the number, a population is having 2 or 3 kids, and other larger test, they were having 4 or 5 kids to just meet up to that population. We also wanted to try to find a good answer in steps. So where the genetic algorithm is going through different generations, we kind of also wanted to take another step of this progress and go through eras. So once it goes through so many generations and the score starts becoming stagnant, it's going to stop and say, okay, that's the best path so far that we found for this far. For the next X steps, let's start again. And it's going to create a new population, a new starting population from there, and start going through the same genetic algorithm, keeping the original first number of steps the same. And then when it moves on to the second, it's going to find the best path from there. So it's kind of like passing knowledge down. And we added these variables here just because we wanted to do multiple testing to find are our ideas actually do they have legs, and to keep the numbers small so the video is not forever, we will tell it to start driving. And it's going through here, it's going through the generations. You could see here that the number of steps that we're taking is only 100. We have a population of 99. And this is the score output that it's getting. And so you could see at this point that it's around 17 or 00, 17.6. And I'm willing to bet that's about where it's going to start staying stagnant unless it gets lucky. But then the moment it increases, once it gets to a certain end, it's going to pass to the next era, and it's going to start taking its next steps. And we immediately increase to 18.8, and that's going to continue growing. And so you could see that those numbers are growing at a pretty decent rate. And once they start reaching the generation near 100, it's going to start getting a little stagnant as well. And then it's going to pass on to the next generation. This is where we do the edit or video magic, and I'm going to cut to the end so you don't have to watch this whole video. And it's probably not going to make it this time because, well, I've only made out to 100 steps. When I run this for 1,000, and I will throw in a small video clip of that at the end so I can run that separately, you'll see that it gets right into the parking spot. Sometimes it's straight, sometimes it's backwards, sometimes it's sideways, but I figure the longer you actually run this, the better results it will get. Yeah, so we did make some discoveries, and we will point those out in our report. Some things that we didn't work, and so we were able to prove ourselves wrong there. But in other steps, there seemed to be slight improvement. To be fair, we're probably not the first people to think about this, since this is our first AI class and we are going after a bachelor's education. But this is a original idea that we had to see if we could improve this, and it helped us understand the genetic algorithm a little bit better.